Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are going to expand e power x log to the base e of 1 plus y using Taylor series expansion. Okay, so I will just show you the Taylor series expansion. This is the Taylor series expansion. If you don't know, I'm going to explain you for the function of x comma y. Okay, so that is going to be f of a comma b plus 1 divided by 1 factorial into x minus a. As we have like a function of x and y, two functions we have, right? With respect to two variables x comma y, or 2 points you can say, or two coordinates you can say, x minus a, that is f of x. Here the order is 1, so we'll differentiate once at of a comma b plus y minus b. We did for x, we are doing for y. F of y a comma b, here y is there, so we'll differentiate once with respect to y. Now 1 by 2 factorial. As here we will have the square, so we are just expanding using x plus a x plus y the whole square, or a plus b the whole square formula. So this is a square 2ab and b square. So this here you can see x minus a the whole square. So the order, or the degree, sorry, the degree is 2. So we are going to differentiate twice. Okay, then 2xy, we have x and y, so we are going to differentiate with respect to x and y. Then y minus b the whole square, so the degree is 2, so twice differentiating f suffix y, differentiating twice with respect to y, plus 1 by 3 factorial. So here 3 factorial, the power will be cube, so we are using a plus b the whole cube formula. So you can just correlate this or compare it with a plus b the whole cube formula. So this is a cube 3a square y plus 3a square b 3a square b plus 3ab square plus b cube. Okay, so here the degree is 3, so differentiate twice. Here the degree of x is 2. Okay, so 2, and degree of y is 1, so y differentiate with respect to this function with respect y once. Then here we have degree of x is 1 and degree of y is 2. Okay, plus degree of y is 3 alone, so differentiating with respect to y alone 3 times. Okay, so we will find all these functions and then substitute in this expansion, and hence at last we will get our answer. Okay, now this is the function given, e power x log to the base e of 1 plus y. Okay, so we will find out, okay, using this Taylor series expansion. So we already know that f of x comma y, okay, this is equals to e power x log to the base e of 1 plus y, and at the point 0 comma 0 is equals to e power 0 log of 1. Now e power 0, this log of 1, how this is going to be like 1 plus 0, y is 0, right? So log of 1 it is going to be, so 1 log of 1 is 0, so f of 0 comma 0 is going to be 0. Done. Now we will differentiate this with respect to x, so it will become, we are differentiating with respect to x, differentiation of e power x is e power x only, but we are not differentiating with respect to y, so this is a constant here, so I will write down the constant as it is and differentiate e power x. So differentiation of e power x is e power x itself. So now I can find it out, f of x at 0 comma 0 log to the base e, this is going to be 1 plus 0 is 1 only, and e power 0 is 1, so 0 into 1 is equals to 0, so I can write it as f of x, f suffix x of 0 comma 0 is equals to 0. I hope it is clear. Now we will find f suffix double x of x comma y, which is equals to, we will simply differentiate this again with respect to x. So this is again going to be constant and e power x as it is. So hence it is same. So it is also going to be 0 only. Now trace x comma y. So again, if you differentiate this, this is going to be same, right? This is constant, again differentiating with respect to x only. So this is constant, this will remain same. E power x is e power x only, differentiation of e power x is e power x only. So this is also going to be 0 only. I hope this is clear now. We have found out alone for x alone. We will find it for y. So f of y of x comma y. So this is the function given as. So if you differentiate with respect to y, this is going to become constant. So I'll write down the constant as it is. Log of any function, that is going to be like differentiation of that is 1 divided by 1 plus y. Okay, and we are differentiating with respect to y, so here we will get 1. No need to mention that. So I can write it f of y 0 comma 0. So e power 0 into 1 divided by 1 plus 0, which is equals to, this is 1 into 1. So f of y or f suffix y of 0 comma 0 is 1. Done. Now f suffix y double y of x comma y is equals to, we are differentiating again with respect to y only. So e power x, it is constant. I can write this as minus 1 by 1 plus y the whole square, right? This can be written as minus e into 1 divided by, I'll write it this separate only, because next time if I differentiate this, it will become little easy for me to differentiate it, right? So this is e power x. Okay, so if I want to find f of y, f suffix y double y of 0 comma 0, so it will become minus e power 0 divide into e power 0 into 1 divided by 1 plus 0 the whole square. So now this is going to become f suffix double y of 0 comma 0 1 minus 1 into 1, which is equals to f suffix double y of 0 comma 0 is equals to minus 1. Now f suffix triple y of x comma y. So I will differentiate this again with respect to y. So e power x will remain as it is. Minus, I will keep it inside like this only. Okay. So differentiation of 1 by x square is minus, I have already. So into minus 2 divided by 1 plus y the whole cube. So I can write this as e power x into 2 divided by 1 plus y the whole cube. Okay. So if I want to have at 0 comma 0, this can be written as e power 0 into 2 divided by, this is going to become 1. So this is 2. So I'll just write it down here. This is going to be 0. So 1 cube, 2 divided by 1 is 2 only. And this is e power 0 is 1. So 1 into 2 is 2 only. Correct? Now we have to find f suffix xy. Correct? F suffix xy of x comma y. So this is nothing but dou square of f divided by dou x by dou x dou y. This is nothing but dou by dou x into the function dou f of dou y. So this is f of y, f suffix y. Okay, we already have f suffix y. So we will write f suffix y. The function is what? The function is e power x into what? 1 divided by 1 plus y. So 1 divided by 1 plus y. Okay, we are differentiating with respect to x. So this will get differentiated and this will remain as it is. So this is going to get differentiated. So e power x as it is. This is the constant. So this will remain like that only. So f of f suffix xy of 0 comma 0, I can write it as e power 0 into 1 divided by 1 plus 0, which is 1 into 1 divided by 1, which is equals to, I can write it as f suffix xy of 0 comma 0 is equals to 1. I hope this much it is clear. Now I have to find f xxy from the Taylor series what you have expanded. These are the things we need to find to substitute in the Taylor series expansion. Okay, so this is nothing but, can I write this as dou by dou x of function f of xy, f suffix xy. Okay, so f suffix xy we already found here, right? So that is nothing but e power x into 1 plus y. We already found this, right? We already found this. This is nothing but moving papers is also become hard. E power x into 1 plus y. So I'll just write it dou by dou x into f suffix xy. I can write it as e power x into 1 divided by 1 plus y. Differentiating with respect to x. So this is constant here. So it is going to be same only. So f suffix xxy at 0 comma 0 is nothing but e power 0 into 1 divided by 1 plus 0 is equals to 1 into 1 by 1, which is nothing but f suffix xxy of 0 comma 0 is 1. Done. Now we will find f suffix xyy, right? We need this to substitute in the Taylor series expansion, that is f suffix xyy of x comma y, which is equals to dou by dou x of function f suffix yy. We have f suffix yy already, so we can just write that function f suffix yy is nothing but minus e power x into 1 divided by 1 plus y whole square. Okay, so I will just write it down, x y y, so that is minus e power x into 1 divided by 1 plus y the whole square. I have to differentiate this with respect to x. This is going to remain constant. So this is going to be as it is only, nothing is going to change. So I can find out f suffix yy at 0 comma 0 is equals to minus e power 0 into 1 divided by 1 plus 0 the whole square, which is equals to, this is going to be minus 1 into 1 minus 1, right? So I'll just write it down so that I can write it in the box. Done. We have got all the required functions, all the required derivatives in order to substitute in the Taylor series expansion. So this is the Taylor series expansion. Okay, using this we can substitute all the values. So what is f of x comma y? F of x comma y, our function. Okay, our function is e power x log to the base e of 1 plus y. So e power x log to the base e of 1 plus y. 1 plus y. Okay, is equals to just take this paper up so that you can see as well. While f of this is nothing but 0 comma 0, right? F of 0 comma 0. So f of 0 comma 0 is 0, so I'll write down 0. Next, what is there? Plus 1 divided by 1 factorial. 1 factorial. Okay, into x minus 0. X minus 0, I'm just writing it as x. F of f suffix x of 0 comma 0. Okay, f suffix x of 0 comma 0 is also 0, plus y minus 0 y. F suffix y 0 comma 0, the value is 1. Okay, plus 1 divided by 2 factorial. Here it is going to become x square. F xx of 0 comma 0 is 0, so I will write it as 0. Okay, plus 2xy. Here it will be 2xy, so I'll just write in the next line, plus 2xy. F of f suffix xy 0 comma 0. F suffix xy, here it is f suffix xy, so it is 1. It is 1, plus this is going to be y square, and fyy of 0, it is minus 1. Till here it is done. Plus 1 by 3 factorial. 1 by 3 factorial. This is going to be x cube. F suffix triple x. F suffix triple x, it is nothing but 0 only. Okay, plus 3x square y. F suffix double xy. F suffix double xy is here, I believe. Yeah, f suffix double xy is here. This is also 1, so I'll just write it down as 1. Okay, x cube f suffix double xy I have written, plus 3xy square. 3xy square. F suffix x double y. F suffix x double y is minus 1, so I'll write it down minus 1. This minus 1, plus y cube. Next line, y cube. F suffix triple y of 0 comma 0 is 2. It is 2. Okay, so it is 2. And still here we have done it, and so on it will be. So we are not going to do that. Instead, I'll rewrite this. After simplifying, we will get, this is going to be, this is 1, this is 0, so y plus 2 factorial is 2 itself, right? So this is going to be 0. 2xy by 2, it is xy only. This is minus y square, so minus y square by 2, plus 1 by 3 factorial. I'm just assuming this is 6. 6 into 0, 1 by 6 into 0 is 0, and 3 by 6, I'm just multiplying this inside. So 3 by 6 is 1 by 2, so x square by y by 2. This is going to be minus x y square by 2, plus this is going to be plus y cube by 3. Hence this is the expansion. If you understood this well, do not forget to subscribe to my channel, share it with your friends so that they can also get benefited from this. Give a thumbs up and write down into the comments if you have any doubts and if you want me to solve more and more problems. Support me, keep me motivated so that I can help you more. Thank you so much for watching.